Section 5.3, now that we know how to add, subtract, multiply polynomials, it's time to learn how to divide them. When it comes to division, there are two types of problems I should know how to handle. One of them is division of polynomials by monomials, so that means the divisor will be a single term. These are super easy problems. The ones which takes a little bit of a know-how is division of polynomials by polynomials. This is like two or more terms. These guys require what? Long division form, correct? So, for instance, what I'm saying is, like case one would be dividing a trinomial by a monomial. Do you see it? A single term. So this is what I'm talking about when I say case one, division of polynomial by monomial. These are super easy. The second is division of polynomials by polynomials. Notice the denominator is no longer what? Monomial. It's a what? Binomial. Whereas here was monomial. So these are the cases where we have to see what to do when you have a monomial and how do you divide when you have binomial or more terms. You may have like 3 terms here or 4 terms, who knows. As long as it's not monomial, then we have to use something called long division form. However, remember the rule of dividing exponents. When you divide exponents, you subtract the powers. What does that mean? That means if I'm asked to divide x to the 12 by x to the 4, there is a 6 here, so 6 goes for the right. But x to the 12 divided by x to the 4 is 12 minus 4, so it's x to the 8 over 6. Final answer. On the other hand, suppose I put the 6, but now I got x to the 4 divided by x to the 12. So turns out because the power of the bottom is greater than the top, so the answer stays at the bottom. So the answer is 6 divided by x to the 8. Do you see it? So the moral of the story is if the power of the x on top is greater than the power of the x at the bottom, the answer stays on top. If the power of the x on top is less than the power of the bottom, x at the bottom, the x stays or your answer stays at the bottom, correct? So with that in mind, let's do this. 12x squared y to the 7 divided by 18x to the 6y cubed. 18 doesn't go into 12, but you can reduce it by 6. So that would be 2/3. 6 goes into 18 3 times, 6 goes into 12 twice. When it comes to x's, which one has a higher power? The one at the bottom. So that will be x to the power of 4, 6 minus 2. But when it comes to y's, the y on top has a greater power than the one at the bottom, so the answer stays on top. That's 7 minus 3, which is 4, final answer. Please do not attempt to what? Change this 2/3 into decimal. The answer has to appear in fraction, correct? So now, let's do a couple of more division of what? Polynomials by monomials. So here is the problem. So what you do, you could what? Split the fraction and write it this way. Right, like so. Now reduce each of these fractions to their lowest terms. So 7 goes into 14 twice. X to the 5th divided by x to the 4 is x to the 1st on top. Then there is nothing at the bottom, but that doesn't mean it's 0, it's just 1. 7 goes into 21 3 times, but the x at the bottom has a higher power than the x on top, so the answer is x squared at the bottom. That's like subtract 2 from 4. So the final answer, you might write it as 2x plus 3 over x squared and box the answer, correct? there's no need to carry the denominator of 1. If the numerator is 1, then we have to carry it. But if the denominator is 1, you can just drop it. What about this guy? Well, let's split the fraction. Okay, like so. Is that right? How many fractions do I have to come up with when I do these kind of problems? It depends how many terms do you have on top. Notice I got 3 terms on top, so I'm going to split the fraction into 3 separate fractions. Do you see it? Now the job is, once I split the fraction, depending on the number of terms on top, you have to reduce these guys, or I have to reduce these guys to their lowest terms. 2 and 9, they cannot be reduced. X squared divided by x is x on top. Y divided by y squared is y at the bottom. 2 goes into 12, 6. X cubed divided by x to the first is x squared. And guess what? Y squares cancel. If the terms look alike, they divide into each other once. Plus, 2 and 25, they don't cancel, so just write it. X goes for the right because I got nothing to cancel it with. But y cubed divided by y squared is y times on top. So what you see inside the box is the final answer. Do you all see it? The second case is a bit tricky because if you haven't had experience with long division form, this may take a while to learn it because that guy was super easy. This is division of polynomials by polynomials. This method requires a procedure called long division method. Well, they will give you a polynomial and a polynomial at the bottom. The polynomial of the bottom is called dividend. The polynomial at the bottom, the top is dividend, the bottom is called divisor. So you always divide the bottom into the top, not the other way around. What does that mean? That means if you ask me to divide, let's say 17 by 4, so that means I have to see how many times 4 goes into 17. Notice, you're gonna go like this. 4 goes into 17 3 times. 3 times 4, you got to multiply these guys to come up with the remainder. Then you got to subtract this to find out what the remainder is. So 4, which was in the denominator, is called divisor. 17, which was the numerator, it's called dividend. Your answer is called quotient. And if you have a remainder, that's called remainder. However, the way we write the answer 17 over 4, we write 3 plus 5 over 4. In other words, the answer in the back of the textbooks is written in this form. So when you have dividend divided by divisor, the answer is quotient plus remainder over divisor. Don't forget, there is a plus sign. Okay, so now how do we do this problem? What you do, you divide the highest power of x in your divisor into the highest power of x in your dividend. So forget about the 5, forget about the x, forget about the -2. Pretend this is what you have to divide. Obviously, the answer is x, so x goes in your quotient. But now I need a remainder. So what do I do with that x? Multiply it by what? The divisor. So what do I get? I get x squared plus 5x. Where does that go? Right here. Okay, what am I supposed to do now? I'm supposed to remember back in old days when we were dealing with numbers, now you're supposed to subtract this number from that number. Here, you're supposed to subtract this monomial from that trinomial. So the idea is to subtract, but I'm sure you guys have seen this. Change that subtraction into what? Addition, but change the signs of these terms. So change the signs. You know why we change the signs, don't you? Remember, when you subtract, there is a minus sign in front of the second parentheses. So to remove the parentheses, we need to change the signs. So what you do, now you can add instead of subtracting, as long as you change the signs. But look, this guy reads x squared plus minus x squared. These guys cancel. But this guy is no longer positive 5x. It is negative 5x. X minus 5x is negative 4x. Then bring down the 20, negative, and continue the saga, which means find out how many times this x divides into negative 4x. Okay, what does that mean? That means on the side, do this division. Divide x into negative 4x. What's the answer? Negative 4, because the x's cancel. Where does negative 4 go? Right here. How do I know what goes in the remainder? Well, hey, take that negative 4 and multiply it by the entire divisor, which is x plus 5. When you do multiply, you get negative 4x minus 20. So that goes right here. So remember, we're supposed to subtract this polynomial from this polynomial. Instead, we add, but we change the signs here. So don't forget to change the signs if you decide what? To add as opposed to subtract. These guys always cancel. In this particular problem, these guys cancel as well because that's negative 20 plus 20 is 0. So the remainder is 0. So this is our quotient. This is the remainder. So what you could do, you could write the answer as x squared plus x minus 20 over x plus 5 equals x minus 4. And there is no remainder. Had I had a remainder, then I would write that as a remainder plus the remainder over the divisor. But in this case, I got lucky. The remainder came up to 0. Okay? So now the idea is how do you let's do a few more examples so we can get used to it. 2x squared plus x minus 8 divided by x minus 2. Remember, the idea is write this in long division form, like so. Okay. And now the saga continues. Remember, you always compare the highest power of x in your divisor to the highest power of x in your dividend. In other words, on the side of your notes, divide 2x squared by x, so that gives you 2x, and that goes in your quotient. Multiply that 2x by the entire divisor, and that gives you 2x squared minus 4, and your answer goes and sits right there in your remainder. Remember, we're supposed to subtract this binomial from this trinomial. We don't, we add, but we will remember to what? Change the signs here, correct? Change the signs. When you do, you can, now this guy is negative 2x squared, is no longer 2x squared. Negative 2x squared plus 2x squared cancels, adds up to 0. Because remember, the first two terms, they should always cancel unless you came up with the wrong sign. But this guy is no longer negative 4x. It's positive x, positive 4x. That adds up to positive 5x. Then bring down the negative 8. And now continue. So x goes into negative, x goes into 5x, positive. That will be positive 5 times because the x's cancel. So 5 goes and sits right there. Now I need a brand new remainder. So what do? I take whatever I came up with, multiply by entire divisor. So the answer is 5x minus 10. Don't forget to add these guys, but before you add, change the sign of these guys to opposite what they are. So 5x negative 5x adds up to 0, but remember this is no longer negative 10, it's positive 10. 10 minus 8, remainder is 2. So either you can write your answer as quotient, here's the remainder, or you can go back to the original problem, say what? The answer is quotient plus, don't forget the plus, remainder over the same divisor. Keep the denominator the same. So this is quotient, this is remainder, this is called divisor. Do you all see it? Right? If you have more terms, so that just means the problem takes longer. For instance, what is x plus 1 divided by x cubed plus 3x squared plus 5x plus 9? All right. So you go, x goes into x cubed. How many times now? X squared time. X squared goes and sits in your quotient. Take x squared and multiply by the entire divisor, and you get what? X cubed plus x squared. Put that in under your remainder. Don't forget to add, but don't forget to change the signs of these guys all the way across. Not just the first one. Every term you see here, you got to change its sign to opposite of what they are. These guys always cancel. But remember, this reads 3x squared minus x squared. It's no longer positive. And that gives you 2x squared. Bring down the 5x, bring down the 9, and continue the saga. So now, once again, x goes into 2x squared. How many times? 2x times positive. So put the positive 2x there. Multiply the 2x by the divisor, and you get 2x squared plus 2x. 2x squared plus 2x. Remember, the more terms you have, the longer it takes to get to the answer. Add these guys up, but don't forget to change the sign of these guys all the way across. These guys cancel. This is 5x minus 2x, which is 3x. Bring down the what? 9. X goes into 3x. How many times? X is canceled. You get positive 3. Put the positive 3 here. Multiply the 3 by x plus 1. You get 3x plus 3. That's your brand new remainder. Once again, you add, you're allowed to add, but don't forget to change the signs here. Yes, change the signs to opposite of what they are. Positive becomes negative, positive becomes negative. These guys always cancel, but this is no longer positive 3, it's negative 3. So the remainder is 6. So you can write the answer as x squared plus 2x plus 3. Don't forget the plus. What was it? 6 over, keep the denominator, final answer. Once again, quotient plus remainder over divisor. That's how the book has the answers. There are times which the problem shows up as good old division sign, which we have learned in basic math. That just means what? Take x plus 4, divide it into what? 2x cubed plus 6x plus 33. The reason I brought this problem up, notice x squared is missing, so I put a what? Space between 2x cubed and 6x, just to remind myself that x squared term is missing. So what do I do if a power of x is missing from the dividend? What you do, you add what? 0, correct, times what? That missing power of x, correct? So what you do, you kind of add 0 times that missing power of x. So for every missing power of x in the dividend or numerator, add 0 times that missing number. What's the job of this guy? This is kind of like what we call a placeholder. So it really doesn't put any dent in your answer. However, it holds the place. Just like, let's say you are on checkout line in the grocery market and all of a sudden you remember you have to rush back and get something else. you would tell the person behind you, could you hold my place? I'll be right back, right? He's not going to pay your grocery bill. He's just holding your place till you get back, right? So in order to what? Not to confuse that, oh my God, whatever happened to the x squared, we usually add 0 times that missing power of x, and that's called placeholder. Okay, so now the saga begins. X goes into 2x cubed. That's 2x cubed over x, which is what? 2x squared, and that goes and sits there. But what do I do with 2x squared? Multiplied by what? The divisor. So you get 2x cubed plus 8x squared. 2x cubed plus 8x squared. And in a minute, you will see why we had to have that placeholder. Do you see it? Add, but don't forget to change the signs. These guys always cancel, but check this out. 0x squared minus what? 8x squared adds up to negative 8x squared. Because there is a tendency among the students, they might say, oh my God, that there is no x squared, so I'm going to combine this with this 6x. Believe it or not, I have seen that happening on the test or quiz. So that kind of assures you to see, look, whatever you get here, because you don't have just like it, you know, the term just like it on top, so this guy transfers over. It never gets to be combined with anything else in the expression. Bring down the 6x, bring down the 33, and continue. So now you go, x goes into negative 8x squared. Okay, that would be negative 8x. So that goes and sits right here. Okay, now you multiply negative 8x by x plus 4. That gives you negative 8x squared minus 32x. Negative 8x squared minus 32x. Is that right? Okay, add, but don't forget to change the signs here. These guys cancel, but remember this is no longer negative 32x, it's positive 32x. So that gives you what? Positive 32 and positive 6 is positive 38x. Okay, it's positive. Plus, bring down the 33. Okay, we still got one more step to go. X goes into 38x. 38 times, so that goes and sits right there. So now I have to multiply 38 by the entire divisor, which is x plus 4. So that's 38x plus, what's that? 152. So that will be what? Let me just write it over here. 38x plus 33. I came up with 38x plus 152. Now I'm supposed to subtract, but I'm going to add, but I'm going to remember to change the signs. These guys always rain or shine cancel. And this guy comes up to negative 119, the remainder. So therefore, I can write the answer as 2x squared minus 8x plus 38 plus negative 119 over the same divisor. Final answer. You all see it? And that, ladies and gentlemen, is how you divide polynomials. Thank you.